Yeah.
It's okay.
The keyboard works.
You can push the button.
Yeah, I'll just push the button.
Not working for you?
Yeah.
It's gotta be something on your laptop then.
This is like a loaner laptop, so.
Whatever.
Let's
Start.
All right, it's 1:30. I think we're going to get started. So this is the software updates for Internet of Things working group, SUIT. Welcome. So this is the note well. You agreed to this when you signed up for the meeting. If you have any questions, please raise those.
However, we should point out this is new for this meeting. At IETF 100, it was different. For example, the privacy policy has been added here. So please review it.
So we have a few administrative tasks. We have the blue sheets starting around. Do we have two note takers or do?
Ted Lemon is one of our note takers, and we have one Jabber scribe, which is
Stephen Banghart is gonna. Are you still able to Jabber scribe? Okay, perfect. So we need one more note taker. Can we have a volunteer? If we don't get one, we can
wait. Come on.
Thank you.
use the Etherpad.
Yeah, if you could take notes in Etherpad, that would be appreciated.
We had that problem with the intro meeting.
We did too, yeah. Yeah, that would be fine.
Jabber was working earlier.
All right, so today we're going to give a brief overview of the working group. We're going to spend some time talking about the hackathon. We're going to follow that up with some architecture discussion. We really like to make some progress on the architecture today, and then we'll follow that by some manifest format discussion as well. Any bashing of the agenda? Okay. So the working group status report. So we've had some activity since IETF 101, where we held up off. We've been chartered as a working group. So thank you to everyone who helped with that process. We also held a virtual interim on February 26th. During that interim, we discussed a few things. One thing being an ITUT SG17 liaison statement that we had received. They'd provided some introduction to some work that they're doing there. We discussed that work. There really wasn't any specific action that was directed to the working group, but we agreed to to continue to monitor the work that they're doing and to try to sync up our terminology where there are opportunities to do so. Right. We also spent some time reviewing proposals for architecture and manifest drafts, and we posted the minutes from that virtual interim. So if you're interested in reading about what we did, you can find them on the SUIT meeting materials page. So immediately after the virtual interim, we started a working group adoption call on draft Moran SUIT architecture, which will conclude later in this meeting. During the architecture section, we'll be taking care of that business. And also we had a hackathon project at this IETF, and we'll be reporting out a little bit later about that activity. So milestone-wise, We are in the process of adopting an architecture document, which is our current outstanding milestone, and we hope this meeting to make some progress on adopting an initial manifest serialization. No, I'm sorry, on adopting an information model and completing the adoption on the architecture. We still have some outstanding work to do on adopting an initial manifest serialization format. So we'll see where we're at on that during the manifest discussion. So overall, we're doing fairly well on milestones. Hopefully after this meeting, we'll be pretty close to caught up. So that's it for the working group status. I'd like to switch to the hackathon report. Let's see. Where is that?
Test. If you guys want to sit down, there's still some space over there.
There's a whole bunch of seats.
Okay. Wanted to spend a little bit of time to talk about the hackathon event, and if you guys have participated there. Next slide. So we had a small group, so there were a number of people. So I sent out an email to the list asking whether any one of you is going to the hackathon and to work with us on a sort of an implementation, early implementation. And we had Brendan, who was not on the picture, but he provided input up front to this work. And you see Alex, myself, Marcus, who is behind from Infineon, Jaime, and Max from Texas Instruments. And we worked together on an implementation where Emmanuel, who indicated on the list that he's going to put some resources aside for a Riot OS to work on an implementation. Also, David from Lenaro, who unfortunately couldn't be here, but he works on MCU boot, and he indicated that he will also work on an implementation, but they have a conflicting meeting, unfortunately, scheduled at the same time as the IETF meeting, and so he couldn't be here. I think it's in somewhere in Asia. Okay, next slide. And so what we try to do at this hackathon is, first of all, to provide some feedback to input to that working group. And by starting off with a signed manifest, so we used the CBOR COSI encoding for that, and sort of the digital signature variant, we used ECDSA. We had to have a way to shuffle the manifest and the firmware to the board. We used this specific board, the Freescale K64F board, and we used the UART to communicate over to that device. Luckily, we had with Max, who has been a developer of bootloaders for many years, so he obviously quite useful expertise to have in the group to put something together, because otherwise that could be a little bit a tedious task to write the bootloader in 1.5 days. And so that was verified there and then installed. Okay, next slide. Now, those were the people I just mentioned. Okay. We got a couple of things accomplished, and then probably the most important aspect here is the links at the end of the slide deck, which provide you to our sort of report, and actually a formatted version which Jaime put together is actually nicely readable. It's a walkthrough, so you can actually reproduce those results yourself if you want to, which includes like setting up the development environments. We used the embed, ARM embed development environments for that. That worked nicely. We got the code working, sort of like, as I mentioned beforehand, the manifest generation, it's a Python code that Brendan wrote, the bootloader, which Max wrote, the UART communication, but of course there's a lot of key generation and stuffing the keys into the right format that is also explained there. Alex has worked on an alternative to the UART communication for shuffling moving the firmware around, and the manifest where he used LoRa. I don't see him now in the room, but there's some information there as well. And this is still the LoRa stuff, as well as the manifest verification is fully completed yet. We ran into some issues, which I would like to report on the next slide.
Wait a minute. Can you tell us what, I think we all know what a bootloader is.
Oh.
What's a pseudo bootloader?
Good point. Actually, the bootloader by itself, that's something probably for the architecture discussion as well. That's also a somewhat complicated concept in some sense, because in this case, we didn't swap out we kept the image that we sent was only an example Blinky image, so we actually didn't copy it to Flash, but instead kept it in RAM and then started it. So in that sense, that's what I call with pseudo, because in reality, you would obviously write the new image that you have received to the Flash somewhere, start the device again, and then jump to the new code to execute that. So that's something we for demo purposes didn't do.
Before you go on, I just wanted to mention, for folks that are just coming in, there are plenty of seats over here if you want to come to this side of the room.
Yeah.
Sorry.
So while the bootloader is a sort of implementation-specific issue, we ran into a couple of questions also in discussions on the mailing list, which are probably architectural issues worthwhile to maybe document or point out. That when we talk about the bootloader code, people were referring sometimes to code that is a boot program that is very small and not erasable. It's like in ROM and starts the whole process. And then the question is, how does the device then use the firmware image to start? Does it actually communicate? Does it have code in there to communicate, for example, with BLE or with UART or with USB or other protocols to fetch a new firmware if something went wrong? Do we have, for reliability purposes, multiple different slots so we can swap over? It's mostly implementation issues, but quite important from an overall design. And I think one of the drafts that we hear about later also concerns that. So they are pretty interesting and exciting sort of design decisions, but and they are fairly complicated as well because you're really working low level. So we probably can touch on this in a side meeting. Brandon is here, who worked on our bootloader, and as we get the some of the other guys who work on bootloaders hanging around here, they can provide that information, but it's a very low level stuff ultimately. Okay, next slide. So unsurprisingly, like this low level IoT development requires a little bit of a steep learning curve. What the most problems we were tackling, and I think that's sort of a call to this group, or maybe even to other groups in the IETF, is we had this format discussion on ASM1 versus JSON versus CBOR, and people said, oh, CBOR is the way to go, and COSI along with it. But unfortunately, the libraries are not yet there where we would like them to be. For the IoT device, we obviously use C rather than Java. The Java library is quite good, but the C library then needs to tie into the crypto, an embedded crypto library, and but currently it works apparently fairly well with OpenSSL, but OpenSSL is a little stretch on such a device. So we needed some other crypto, which is of course takes some time and examples and all the functionality. So there's a lot of more work to get it to a stage where we can actually use it in a real production code. So and since this is a dependency, to get really moving something forward, I think anyone who is interested to make this really happen and to provide reference codes like we have in other working groups, I think it would be great to get together and actually work on something together, something that also has a reasonable RAM utilization. It's maybe good if the code is small, but then...
Mike, please.
Mike, the mic is over here. So do we have a choice of a library? Yeah. Of course. We can choose whatever we want. Yeah, no. Well, there is only one. So in that sense, the choice for our hackathon... Okay, yeah. We I on a slide deck I just wrote an embedded implementation, but we had used the embed DLS for selfish reasons. But of course, other implementations, other embedded crypto implementations would be fine, of course, as well. But it should still, like as a minimum requirement, it should fit on a device, right? We want to have not only something that is small on the wire, but actually then fits on the device in RAM and flash as well.
Yeah, Thomas Schmidt, Hamburg. Yeah, that's obvious. I mean, there are a couple of implementations for this. I was just asking what library you actually had at, or what you would prefer.
We used the COSI-C. So that, Markus, correct me if I'm wrong, but we didn't actually find multiple C libraries that COSI-C libraries that implement use embedded crypto and implement the signing, the digital signature algorithms.
And the name?
No, there was only one we found, COSI-C. It's called COSI-C.
Yeah, Markus Güller. Yeah, we've been looking, but the only one we found or we've been aware of is the COSI-C. And we've been using this because it's sitting on top of CN-CBOR. And this system seemed to work together pretty well. So we've been choosing this as a starting point. Yeah. But if people have other experiences or ideas of a COSI library, of course, we are open.
Yeah, is anyone in the room aware of any other implementations?
Well, in any case, I thought it would be good to bring this up because, like you hear on the mailing list, we had all these discussions on what formats we should be used, and we were told that COSI is sort of the right thing to do. But then when we get together at the hackathon, we then realized that, oh, damn, nothing works. The stuff doesn't even compile. So we got a little bit frustrated, and I wish you were all there so you could have shared our frustration. But the manifest functionality, which we tested, that was fine. That was just the basic functionality. And in future, like there are definitely other things that if you have students or if you for yourself want to participate, like the post-quantum crypto mechanisms with the hash trees that Russ had been proposing, or also the use of group communication, or a couple of these other, so multiple signing concepts, etc., that would be very worthwhile to experiment with. So we can actually get hands-on feedback, not just talking about it in or just writing documents about it. The running code thingy. Okay, I think that's it.
If there are volunteers that are interested in working on these kinds of implementations, maybe we can like gather after the meeting and have a short chat about that.
And it's also, at least for the hackathon, there was an incentive because we handed out boards. And so if you volunteer to participate, you get a board, development board, IoT board. So maybe that provides a little bit of incentive here.
All right. Yep. Yeah, thank you to Hannes and all that participated in the hackathon. So now we're to Julian, are you here? Yes. We don't have one.
Thank you. Good afternoon, everyone. I'm Julian from Huawei. Today I'm going to talk about my proposal and a secure and automatic firmware update architecture for IoT devices. Next slide, please. The background of this proposal is that the Suite Working Group is working on defining a secure and interoperable firmware update solution. And the existing, I think the key security is the key feature of this solution, and existing drafts, proposed by ARM and Cisco are more on the cryptography and integrity aspects. So this draft is more on the availability aspect. Next slide, please. So the reason why I want to propose this one is because the Dying cyber attack. One of the root reason is that the devices are not updated in time, so that they are hacked by with the default username and password by brute force attack. And I analyzed some existing firmware update mechanisms like OMA DM and lightweight M2M. I found that they are more on the device side, which means that they use an idle status as a trigger. The device downloads the firmware images, and when it comes to the idle status, and then it starts the update process.
This is Hannes. I would like to ask you a few questions on this, on the idle status. So I wrote a part of the text in the lightweight M2M specification on the firmware update mechanism and put a state machine there which has an idle state. And maybe that was confusing or misleading because it didn't really mean that the device wasn't doing anything or needs to be in a specific state, but it was just a start state in that specific interaction. How you actually get there to do the firmware update depends on your design. So, for example, in a previously mentioned bootloader, in this case, if you don't have IP communication in the bootloader, you somehow have to get into that state, and so you would get the firmware image sent to the device using your favorite networking protocol. In this case, it's co-op. You get that, and then you need to invoke the bootloader to go into that phase to actually analyze it and to do all the steps, and then to swap out one image against the other one. So the idle doesn't really mean that the device doesn't do anything. It's operating, it gets the update, and then it needs to apply that update. Brendan, do I summarize that? Yeah, correctly. So I it feels that, or to me, like reading through the document, you got the impression that the devices don't do anything, just sit there and have no operations, while of course they always do something, or if including sleeping, or sleeping most of the time. And so there's probably not that worry. Do I express my thought here clearly? Because you look a little confused. Okay. So in a nutshell, I don't think this is these existing firmware update mechanisms actually have that limitation.
I think we're going to go to the remote. Please go ahead.
Hey, Hannes, this is Raj. So regarding your comment, I'm not doing in the context of lightweight M2M and what I see the statement, it is really in the sense that I differentiate. The client is always a command that so it's always, I mean, and I interpret this comment here you can program to periodically check in and things like that, but that's generally not the model, right? I mean, you generally want the server to initiate any sort of updates, right? But the client is always in a listen mode. I mean, it will respond to any triggers or communications originating from the server side, and that's what I think. The author of this draft here is trying to say.
Okay, thank you.
Okay.
At the mic.
Chen Hanxiu from Huawei. Yeah, just also comment on the idle state. I'm working in the wireless product. In the wireless, there's introduced a lot of idle states. For example, in the 4G, there's a power saving mode for the IoT and M2M state. Also extended the DRX. In the 5G, now that they have agreed to introduce RC inactive states. Also, they are also want to introduce something like RC resume and suspend on consume status. So for the wireless product, there's a lot of idle states to save the power on the UE side.
Okay. Okay, for the idle status, yeah, actually, I propose two cases. One is the smart meters, and another one is that the ECUs in connected vehicles. And I mean the project I'm working in is see that especially for the gasoline cars, the ECUs you can update ECUs only when it's I mean you have to stop ignite the car and stop it without doing anything and do the OTA services. Then I mean the idle status of the ECUs is I mean the human intervention thing, not you know you can update the ECUs when it is running. I mean the car is running on the road. That's another the other case. Or if you want to see the ECU in the idle status with without human intervention, then it's not possible. But for now, because every time when the ECU goes into the idle status, the car is also shut down. I mean, so yeah, that's why I propose this draft. Next slide, please. So in order to I mean to strengthen the automatic feature to update the devices in time, I propose this architecture, which the server gets the firmware images and manifests from the author, and then the server can check the manifest to see if the which the device is their target device, update device, and to see the urgency levels, updating urgency levels, update the urgency, and then this device and server do an update process. This can, I mean, this automatic update can update the device in time with the least human intervention, and different devices have different update urgency levels, and different firmware images for the same device also have different update urgency levels. So my proposal is that we should leave a space for not only the device side, but the server side could do something to improve the automation or automatic level of this update solution. Next slide, please. Then in the update process, I think there should be 3 modes. The first one is client-initiated one. The client itself pulls the latest firmware information from the server periodically. And I think it's more for the capable devices. And the second one is a server-initiated update. And especially for the constrained devices, it pushes the latest firmware information to the device. And once it gets the latest images from the author. And the third one is a negotiated update. The server only notifies the firmware image information to the client, and then the client decides the update timing. I think this mechanism, the third mode, is very mature in the mobile and the desktop environment. Yeah, that's That's all for my proposal.
This is Dave Taylor from the floor mic, so as a participant. I like this slide. I think this slide is pretty clear, and I think that so when I reviewed the other architecture document, I had some comments about some cases where I thought it was unclear. I think this slide is actually a good contribution, in my opinion. One of the things that our charter says is in scope is architecture, but the actual details of the protocol to transfer the stuff is out of scope. And so the architecture has to be capable of dealing with multiple protocols that we're not going to do. So I think this is actually a good taxonomy. The other architecture document that Brendan and Hannes' and stuff, the example that fits sort of your previous slide is a short version of. So section 7 in the other document has this long example flow that fits into one of these three, and it only shows one example, right? And it's a case that fits into I think it's the client initiated updates, the one that's in that one right now.
Yes.
And saying there's actually a variety of possible ways to do it is actually, in my opinion, appropriate for the architecture. And all three of these, I think, is actually a good way to express things. I found this to be a useful way to express things. And so I'd like to see this type of taxonomy or whatever rolled into the other document. And so I think this is a good contribution. I think this slide actually, in my opinion, does a better job than that part of the other document. I'd love to see this pulled in.
So Hannes, you first.
Yes.
Go ahead.
Hannes, the question for me was how much should the architecture document describe, particularly considering the scope of the working group, because there's a lot to talk about potentially, and that could be informative, but has little to no reassemblance on what the group actually really does. For example, at least at the moment, the charter doesn't talk about how these updates are done using whatever protocol. It just says it somehow gets there, and then that's where the show starts, from a parsing of a manifest and getting this stuff updated. Also, as previously mentioned, like the architecture of the bootloader may also impact some of those things. Specifically, if you want to talk a little bit about the failure cases, because that's when things get interesting, so you don't break your device. And do we want to, and that's a decision the group needs to make, do we want to document those, or do we want to stay closer with what is worked on in the group? At the minimum, I would expect that we would make clear on what is currently being done, and rather what is being dealt with elsewhere. For example, as you nicely illustrated with the lightweight M2M protocol.
So Dave Taylor, all three of the different contributions in architecture did cover some protocol-like stuff. And so since we're doing a manifest format, I think the job of the architecture document is to set sufficient context that you can actually evaluate whether the manifest format stuff actually meets the needs of the people that would use it. And so in that perspective, you got to say enough about the protocol use cases without going into the details to say why it would be relevant. I think the level of detail that's on this slide right now is an example of what, in my opinion, is an appropriate level of detail to say, look, there's different ways that you might use it. And then you can evaluate, is this manifest format that we're doing, does it make sense in all three use cases? And you can look at that and say, yep, we can meet any of those, and in which case we've convinced ourselves that it really is agnostic to what the protocol details are. So I don't think we should be going overboard and saying what the protocol details are, but if there's taxonomies along the level of details on the slide right now, I think that's actually very useful to set the context so that then that lets us evaluate the manifest format.
Hold on one second. We're going to go remote and then back to the mic.
Yeah, Raj Patel from AT&T again. So, from an architectural perspective, as Dave was mentioning, I agree with his comment, right? But one of the things that, more specifically, we've never, at least in a lot of the IoT scenarios, we never want the client itself to initiate an update, right? I mean, a client can check in, and, when it does check in, it provides its current version of the software. But the update is always controlled and triggered or managed from the server side, right? I mean, the client never actually initiates an update. And I mean, in the context of previous protocols like OMA-DM that have been used on the cellular, your smartphones and things like that, That is true, right? I mean, wherein the client has a periodic timer and then it checks into a server and sees if there's a new firmware version and so on. But in the context of IoT, I don't think that you would necessarily want to really have clients initiate that. Just my opinion anyway, but from an architectural, if we're at the level of talking from an architectural perspective, I think capturing this is actually good. Thanks.
Thank you.
This is Brendan Moran. So it seems to me, from what I've seen, that there are a really wide variety of different distribution models, and this may capture them all. I'm not actually convinced that it does. And that's where I have to ask, should we be capturing them at all? The key point of the draft was to identify the separation between the metadata and the actual payload, and the fact that those could be distributed separately. What the exact process by which they get distributed seems out of scope to me, just because there is such a wide variety of possible different mechanisms. And if we start nailing down exactly which ones we expect, then that limits the scope for innovation later on top of this work.
Russ Hasley speaking as a participant. When I was working on RC 4108, which is how to sign firmware packages using CMS, I found that you had to do some minimal description of what the bootloader did or did not do in order to talk about anything. And for example, always has the capability to validate a signature would be one kind of thing we'd say. And I think those kinds of minimal capabilities have to be documented in the architecture.
Transition. Because for the IoT device, there's I just say there are lots of idle states, something like a sleeping state or hibernate state. Before the server say something, notify to the client, I have something need you to download. The server first to make the user wake up. This in the CPP they call it device trigger. They need to make the UE wake up from sleep or hibernate status. Then the client can talk with the server. I don't know whether this activate make the UE side or client side wake up is included here or not.
I'm not responding, so if you're answering, go ahead.
Quickly responding to that, Hannes. Yeah, that's a tricky thing, and I think this is what Brandon was alluding to, because you very quickly cover a fairly broad scope, and clearly for some of the cellular IoT devices, that's an important question of like, the device is sleeping, somehow it needs to get wake up and woken up, and there are different ways to do so. For example, an SMS trigger or so, and the device comes up and then interacts with the server to actually get some data, whether that's application data or happens to be a firmware. But it's nothing, it's interesting information, and there's specification, this is documented in the specifications elsewhere, in, for example, lightweight M2M. But the question to me is, while interesting, should we document these type of mechanisms? Should we talk about them in this document? And I don't know into which direction the group is sort of heading to on that, whether they want to have a sort of a more illustrative document covering a wider range of topics, including the topics that Russ raised with the bootloader as well, or not. But it should be more shorter and more focused on what the group is chartered to do today.
Dave Taylor, participant. I just want to give a quick example of something as to why I think this taxonomy on here is useful when we get to things like the information model discussion. An example of an attribute that's discussed in the Brendan's document right now is the server location for where to get the firmware update. looking at this slide, this gives you enough information to be able to tell, well, for example, I absolutely would need that in the third case, right, where the firmware image info comes across and is pushed to the thing, and then he has to know which server to go to, right? It'd be very appropriate for that. But in the second case, if you had a protocol that was designed a second way, there would be absolutely no need for that, right? And so this gives you a way to evaluate that says, okay, well, I know that we need to allow for this, but it also must not be mandatory in all cases because it would be overhead in category number 2. I don't want to dive into that example too much. I just want to get in your heads why I think this is a useful prerequisite to discussing which things have to be in there and which things should be allowed to be in there but shouldn't be mandatory in there. You got to have this frame of reference in order to have that discussion, and that's what I find this useful for.
Yeah, for the solution 3, the server notified the firmware information. Well, I just said that if the server trigger the UE, then UE actively connect to the server. In such case, the server will provide such phone information to the UE side or client side. In such case, it still use the, now it comes back to the client side solution, the solution 1. So my understanding, just some people, just the guy says that there's a lot of combination or possibility. Maybe we do some very basic, some basic solution to downlink the image. Then other solution is trigger to use this solution. Maybe there's some, forwarding.
Can I say something? Yeah.
Oh, sure.
Yeah, these 3 modes in my draft, let me take server initiated update mode like as an example. In some cases, especially for the extreme constrained devices, it is for the efficiency consideration. It is not. I mean, it's not. I'm sorry. It's not need for a device to know why should I update at any time. The server knows it, that's enough. The server just trigger the device to update. Yeah.
This is honest. I wanted to respond to Dave's sort of remark. I think at least the first 2 categories, it's sometimes a little hard what that actually means, because here it talks about pushing the client-initiated update for firmware, but what about then about the manifest itself? So imagine I have the server pushing the manifest, but then the client actually fetching the firmware. So
Push manifest full image. Yes.
I'm not sure. It only talks about the firmware image, notifies the firmware image info. Is that the firmware? Is that the manifest? I think that we need to clean up the terminology and also.
Sure. Push manifest full image.
Yeah, and also the trigger that was just mentioned is a trigger server initiated, or is it like also the performance argument is a little bit tricky. Because ultimately the performance hit will really come from the fact that you download the firmware to begin with. That's a heavy beast. So yeah, I mean, I'm not against including that description, but I think we need to work a little bit more on it for sure.
Robin Wilton, ISOC. This is kind of the same point, I think. I just wanted to outline maybe some cases where you definitely want 3 negotiated update, and you might actually want to insist on 1. And those are cases where what the remote device, what the client device is doing is time critical. So for example, in Prague, I remember at the tech plenary, one of the examples given for IoT in vehicles was that something in the vehicle should alert the driver when there's an emergency vehicle coming up behind them. That's something that you don't want to delay while you're doing the firmware update. So the thing in the device in the vehicle has to not only know that there's an update waiting, but some component has got to make a judgment as to whether it's an appropriate time to engage on that update. Thank you.
This is Brendan Moran again. So I wanted to elaborate on three new modes that we have missed here, because this is why I was trying to say earlier that we are limiting ourselves. So you could have a gateway initiated update where the device is not talking to a server, it is in fact talking to a gateway, and the update is being initiated by the gateway. You could also have a peer initiated update, which would be the case in mesh distribution. You could also have a local storage device initiated update. So where you plug a USB device into your IoT device and that initiates the update. If we start describing modes, we're going to have an enormous description of modes by the end of it. And I think that what we're doing is creating a huge exercise in documenting modes when it's perhaps not actually necessary.
So Brendan, it sounded like some of those were actually subcases of those three as opposed to a fourth, fifth, or sixth, right?
How does a peer initiated update fit into those?
From the perspective of the client, it would be server initiated.
Is it though? Because the device may have dedicated communication with the server through a mesh, whereas a peer initiated update isn't the same thing.
Yeah. So
the point I'm trying to make is that we're getting back into, we're trying to classify things a lot, and I'm not convinced that that's actually going to be helpful in the long run.
So what I'm hearing from myself and others, and so I may be biased, let other chairs correct me, right, is that from the perspective of the client, the first mode is that the client pulls both the manifest format and the image, and that's number one. Number two is from the perspective of the client, something else pushes to it both the manifest and the image. And number three is from the perspective of the client, something else pushes the manifest and it pulls the image. That's the definition of 1, 2, and 3. And the other ones are subcases to what the something else is. Okay. I see a couple nods in the room, both up here and out there in the audience.
Just as the person trying to take notes on all of this, would it be simpler if we said self-initiated, initiated by other, and negotiated? That seems mutually exclusive, collectively exhaustive.
That is what I'm hearing, yes.
Okay. Thank you.
Okay. You agree? Okay. Okay.
Okay, thank you.
Okay. So we had another update of the document before the IETF meeting, and Dave started a call for adoption on the document. So I briefly wanted to go through some of the text, and there was mainly this discussion that wasn't really resolved. So I would like to get your feedback on that. And we also made some changes to the appendix to improve readability as requested during the virtual intro meeting. And I haven't heard any negative feedback since then, so I assume that has been done okay. Okay, next slide. Hey, Dave, can you? There was we had a fair amount of terminology discussion. It was also partially triggered by the liaison from the ITOD that was mentioned earlier, and because there were a few terms that seemed to relate to each other, others that weren't necessarily overlapping. So this is, we only have a few terms at the moment. I clarified them based on the discussions. There's the manifest, which contains the metadata about the firmware image, and that's the one that is protected against modifications. That's where I mentioned this in the hackathon about the signature that wraps around it. The firmware image itself, it's a binary and may consist of multiple images, maybe just a differential update as well. And maybe also from early discussion, maybe the entire image or just parts of it, just an application or a stack rather than the entire image, which again is different than a differential update. So we didn't want to constrain that further in the work. Okay. But the manifest actually describes on what format the firmware image is. It may be SREC, but it may be Intel hex binary. I mean, who knows? That's also, I left this terminology in there, although we had the discussion. I made some alternative proposal. Russ, you chimed in on that debate, but we didn't really reach a conclusion on like what terms we should be using. And I'm also not entirely sure whether we want to align with some of the IETF terminology on that topic. So would appreciate your feedback here. So we had this author terminology to indicate that there's some party that signs or creates the firmware image and signs the manifest and distributes that together. That will be a developer, typically with the use of some tools. Maybe also a quality assurance department who decides about the distribution of all of this. Maybe also an IDE. Then the device that is ultimately the recipient of that firmware image, and it has to take that, the manifest and also the firmware to sort of ultimately make the decision on whether to install the firmware image or not. And then we had all these untrusted storage in between, which sort of, we had a separate figure on this end-to-end security concept. And we talked about this different distribution mechanisms a few minutes ago already. Okay, next slide. So I'm not going to go through this end-to-end security discussion, but focus instead of the new figures that I had added. It was referring to the IETF terminology, which relates also to the question of how broad we should document things. For example, this, if I understood it correctly from Dave's explanation, there was also this concept of a tracker, sort of the server tracking the status of the firmware update, which is something that we certainly haven't documented yet. So I don't know how far we want to go there. Next slide. We had also a couple of requirements in there which triggered some discussions. So there was there was the requirement to use state-of-the-art security mechanism, and Marcus mentioned that we should indicate some minimum security level. So I indicated that based on what we use in the IETF. But there was also the issue that came up with the role of post-quantum secure crypto mechanisms, particularly given that when we talk about these bootloaders, which may not be updated and devices out in the field for a very long time. So how do those actually play a role here right now compared to some of the components, the application components that use security that get, via these mechanisms, get updated very regularly, where you can swap out algorithms as you need it, versus the bootloader, which will not have that possibility. So that's something I myself don't have an answer for. So I don't know. There's also Marcus raised this question on the state-of-the-art mechanisms, like what should sort of be the minimum to implement security mechanism be? Because we have also the constraints, so we can't just have, let's say, one mechanism, whatever it is, ECDHE, ECDSA with, let's say, AES 128 CCM implemented, but then others want to do something else. Do they always have to implement that algorithm? Also not clear on how that would work, and also with the relationship to what the bootloader needs to do. In general, currently nothing in the document really talks a lot about the bootloader, which Russ raised on the microphone earlier. So maybe we need to think about that as well. Okay. Next slide. So there was we added a few figures based on the discussions at a virtual intro meeting, and specifically on the difference between attaching firmware straight to the manifest as it gets delivered, or as the next slide indicates, detaching the two as a delivery mechanism where the manifest is provided or distributed in one way and firmware is updated or distributed potentially in a very different way. And obviously those use cases have a direct implication on the design of the manifest format, because you need to have the corresponding fields in there to make this happen. Okay. Yeah, the appendix got updated to include some of these additional threads and user stories. I won't go through them in detail since I haven't seen any further comments on those, but I believe they should be fine now. So in a nutshell, so I heard from the previous discussions that we should work with the also of the other document that describes the different delivery mechanisms, but and also include some text on the bootloader mechanisms as far as it impacts the sign of the manifest format and also the delivery mechanisms. I'm not sure whether the what the answer is for the state-of-the-art security mechanism and whether that's what's currently the document is actually acceptable. Marcus, maybe you have some additional views on that? No, everything's said on the mailing list on that topic already. So you're happy with the text I provided, I suspect. Good. Okay.
Yeah.
Okay.
List of bullets that I had in my review to see if there's any comments on any of those from the general, because there's a couple of them that are useful to at least draw people's attention to and see if we have any discussion here. So I had sent a review to the list the other day, and where the summary was, I didn't see anything there that would block adoption. There are things that the working group should do. In fact, one or two of them are things the draft itself called out that I added into the list that says, okay, the draft needs to figure out what to do about X, right? And so those are things that the working group would need to do, assuming that this gets adopted, which is kind of the where I'll go to in a second here is to conclude that call. Yeah, that's it. So if you can scroll up. So I'm going to skip 1 and 8 because that's part of a later agenda item when we talk about information model that Dave Waltermeyer is going to cover. So I'm skipping 1 and 8. And so I'm going to briefly walk through just 2 through 7 just to see if there's any comments here. Otherwise, we'll list these as things that the working group needs to spend time on between now and the next time that we have an interim meeting or discussion on the list or whatever. But in case, so number 2, the abstract itself has this comment that says, right now it's scoped to be asymmetric keys. And there's this sort of implied question of, should it cover, is there a need to cover a symmetric key solution or not? Okay. And since the document itself calls this out, okay, we could choose to say we're going to rule that out and not going to work on it. We can say it is something that needs to be done and ask for volunteers. We can just remove statements or whatever. And so I thought I first asked the room, since the document sort of did that, nobody commented on that, to say, do people know that there are use cases, because if there are, the architecture document should cover them, where symmetric key cryptography is actually needed? If nobody knows cases that they're needed, then we could just remove that one sentence or whatever. Okay, if they're needed, that means we need some more work.
Brendan speaking here. Yeah, they are definitely needed from what I can tell. And so, I mean, we've already got some ideas of where to go with it. So maybe it's just a matter of updating the document.
Okay, so then it becomes a work item that we need work, as the document suggests that it should be done in the future, but doesn't do it. And if we want to do it in the same document, that means it needs to hit the same timelines. Okay, we could say, well, we could do that in a separate version and do it in a separate document or whatever. That would be a choice we could make. But it sounds like right now, your recommendation is it has to be done in the same document, in the same time frame before we're done, if you think it's actually a requirement. Okay. I don't hear anybody jumping up and objecting to that. Okay. Let it be noted that there are no objections to that opinion from the authors. Okay. The next one is, Hannes, you already covered this one in a slide, where it would be useful to describe the 4 roles in the context, because I think that makes it be more usable by other orgs. Okay. Even if we say what we're concentrating on is the relationship between these 2 or 3 entities or whatever, it helps us at context. So that's number 3, but since you already covered that, I don't have any questions to ask there. Number 4, it's a little bit confusing as to what it means. Let's only break it down into 2 questions. One is about how much of the protocol you need to discuss, and that kind of fits back another time, which we kind of said as little as possible, but only enough to actually motivate what the requirements are later on. Okay. The other part is there's a sentence in there about the requirements for security, and the question, which I think is intended to motivate why you need security, like signatures in the manifest itself. I think that motivation is that. If there's some other motivation behind friendliness to broadcast discovery, that would be something we need to input from the working group, because I couldn't get anything else out of it other than that one thing, which I agree with. Okay. I think it says, like, you can't use link layer security or transport layer security. Well, that should be, just cleaned up to said, you may not be able to rely solely on that or whatever it is. Okay. There's nothing to talk about here. I'm going to go on, but that's what that one was about. Yeah, go ahead.
Yeah, the probably two aspects to this. One is the distribution, the firmware distribution to multiple different devices, which could be elaborated on more because it's very brief.
You just reminded me of the other question.
Yeah.
Go ahead.
The other aspect is, which is also touched on in the document, is the question of in the use of encryption, and then the case where the firmware image itself is protected or encrypted with a key, with a symmetric key, and there's obviously you want to have, in some sense, make it broadcast distribution friendly in that regard.
Right. Yeah, the text that's, because it's only like one paragraph right now, the text in there is a little bit ambiguous as to whether it's talking about broadcast delivery of the manifest or broadcast delivery of the image or both. And so it sounds like there's actually cases for both, but the language is a little bit confusing. So I think this one turns out to be mostly editorial if we understand, if we're kind of in principle agreement on what the intent is. So, okay. Number 5 is the one that you already mentioned with Russ, which is to what extent do we want to cover quantum resistant signatures, where I think right now there's a bunch of people that would argue yes. Anything else you want to say about that, Russ, as to is it something that we think needs to be covered in our first version?
Well, first version, no, I don't think it's a blocking thing for adoption, but I'm advocating we pick a quantum resistant signature as the mandatory to implement.
Where I think the argument that I've heard is if you don't put in the option now, it's really hard to do it later once the device is out there because you can never trust your update, right? If you've been hacked by a quantum algorithm.
So the short form of the argument is, from the experience of transitioning from SHA-1 to SHA-256, we know that's a 5+ year effort. So I got to believe transitioning from a elliptic curve or RSA-based signature to a quantum resistant one will be a 5-year effort. So if we don't put this in now, there will be devices that are using those algorithms potentially when a quantum computer comes to pass. And so if we want to sign the firmware that implements the next generation crypto with one that is not resistant to a quantum computer, we're going to be in a situation where how do we get there from here? Don't want the answer to be we have to physically touch each device to make sure it got the quantum resistant signature into it. That's the whole point of this exercise, right?
And the document does have a little short blurb about it right now. So
The downside or the tricky part of that story is to know what we should, like in the architecture document, one could get away with a very high level description of the issues, and that's good. And we haven't done that. And there's some text potentially in the workshop that IOTU workshop actually.
I remember that.
Yeah, I think you provided the workshop. But to finish that sentence, but then when it comes to actually using the mechanism there, it gets tricky because the performance of most of them is disastrous.
That's not true.
Well, at least the public key mechanisms that I've seen are
Not true.
Not true?
Not true.
Okay. That's good to hear, but they are not finalized yet, many of them. Is that also not true?
That's not true either. Okay. So in the CFRG, the next session, the Cryptoform Research Group is working on 2 hash-based signature techniques, and they have slightly different properties, but the bottom line is they have very small code footprints, very fast signature validation, but large signature values. And given this application, where you're going to amortize the size of the signature across a firmware load, the large signature values is more acceptable than, say, signing a certificate with it.
Peter?
Peter Koch-Dienig. I have a question, maybe picking up from what Russ just said. So when I read this, I was wondering what this is about. So the explanation is great, but it made me wonder whether that is not related to the general key rollover, algorithm rollover, and trust anchor management question. And I didn't really see that explicitly mentioned in any of the documents. Is that maybe a broader
The
catchphrase?
original point of this being on the agenda here is to say one of the things that should happen in this document, assuming it becomes a working group document, which is a future slide as to that question. If it does, then this is something the working group needs to spend some time on, is to craft, because it's really, if we believe it's a requirement for the manifest format to support such and such, then the architecture document needs to motivate that with a paragraph, which it kind of does, could be cleaned up. And then the manifest format needs to actually have a way to do it. Okay. And so the manifest format is a separate document that we need to put effort into to make this algorithm or an algorithm be usable.
Yeah, just saying that
So
mentioning
please
of post-quantum cryptography as a metaphor for the broader thing is maybe a bit cryptic. No pun intended, actually. So if you get that, then I understand this is not solution space. Sure,
Yeah.
thank you.
This is Brendan. I think there's one other point to draw out here, which is that the current draft of the manifest specification actually calls out COSE as the signature container. So it seems to me that if we're going to start talking about quantum resistant signatures, the correct place to do that would be in the COSE spec.
That's a valid comment.
Yep.
Yep. Okay. I'm going to go on. Number 6, the first half is editorial. The architectural question is actually the mid one, which is it safe to assume that the device owner and operator is the same as the network owner and operator? My personal contention is, no, that's not a safe assumption in all cases. The document kind of convolutes the two right now, and it would be good to be explicit and say device owner or operator, which may or may not be the same as the network owner or operator. And so cleaning up that language, unless somebody believes that, oh no, we need to scope it to a case where it's always the same, that's the architectural question. If people agree that they may or may not be the same, then there's no architectural question, that's just an editorial point. And I see Brendan nodding, and that, so unless somebody comes up to the mic and says, no, there's an architectural thing, they have to be the same, then we can go on and say this is just an editorial thing.
Michael Richardson. And you asked the architecture question, and I think to me the architecture question is, does the device do all of the determination as to what is an acceptable update, or does the device mandated accept updates from a single entity, which is one of the things that you mentioned before, which may or may not be the same? Okay, and but that's not to say whether the manifest can have, you know, really complicated statements. The device may not simply not trust those statements until they're signed by the thing it expects. I think that's an architectural question as to whether or not the device must do all the validation, whether the device can anticipate help. And I think that this matters to the architecture. And it's not to say that devices couldn't do it all. Right, but that they don't have to depend, that we don't have to depend on that there. I don't have an answer for this, but I think it tweedles the question of owner operator completely, just as, well, no, that's not an issue. Okay, it's you can have as many owners and operators as you like, as long as the device understands who its mummy is. Since we're in London, I can use that.
I think you ended up rephrasing the first part. I think is prerequisite to my question. My question is sort of, you know, we had this discussion at the intro meeting and at the last BOF about the notion of countersigning, and so you have the author of the firmware, and then you have the entity that says it is appropriate. Okay.
Right.
And so we said, okay, there has to be at least, you know, 2 signatures to cover
that was your owner operator.
And the question here is that okay, or is there any case? A variation of the question, which you kind of got to at the end, is there ever a case where you need 3? Because your device owner is different from your network owner. Is there ever a case you need 3, or is 2 sufficient? If you can argue 2 is sufficient, then yeah, you can just say the device owner is the only one I need to mention. I don't need to mention the network operator, because I may or may not be, but it's the device owner that I trust. If you care about a case where you may need 3 guys to participate, then it gets to be even more complicated. And do we care about that? Right? I only know of a case that would need 2, right, which is the device owner and the firmware author. I got that one. If there's a third case that says, even in addition to the device owner authorizing stuff, I need the network owner, who may be different, if he is different, to also authorize it. So I need 2 counter signatures. That's a case I don't understand yet.
I think self-driving cars come there because there are updates where the owner of the vehicle, you, okay, can say, I don't want to update right now. Because I am going on a trip and I do not want any changes to my automobile while I go on this trip until I return to my home where I can deal with issues. And we all have this issue with our laptop. Don't upgrade your laptop the day before you travel to IETF, right? I'll do it when I come back, okay? Meanwhile, the owner of the vehicle is like, this is a really important security update. You need to apply it now or soon or something. And then we have a third thing, which is, you know, the Department of Transportation or whatever that says, you will not operate your vehicle unless you are at least at this state. And the vehicle respects that point. And so it won't let you go on the trip. Okay?
Sounds like you're arguing, yes, the architecture should be flexible enough to assume one or more signatures.
One or more.
And we
right.
know of use cases, like you gave a use case, you're arguing that there's potentially three.
There's three. I just made up three, and we can easily come up with 4 or 5.
Bake in the notion of exactly 1 or 2 is what you're arguing.
So,
Okay.
but my real question is not should there be 3 or 4 or n? Okay. My real question is it reasonable in the architecture that the device can say I only support 1, and I support offloading that trust decision, complicated one, elsewhere? And I think that's an architecture question.
This document, I think, already allows for the answer to that to be yes if you want it to be yes. And it's flexible enough that is one of the possible cases.
Then I actually would argue that the case of 2 signatures is complicated enough already that it should always be offloaded, and the device should only have to ever trust 1, and that anything larger than 1 is equivalent to n.
See several squints out there,
Yeah.
constraining it to kicking out use cases. I don't see people's faces in favor of that, but that's my reading. So.
Well, that's what I'm saying.
But I also see a long mic line behind you.
Yeah, thanks, bye.
We're going to go to Nedeco first. Please go ahead.
Yeah, Raj Patel again. So with respect to the question of whether the device is owned by the operator, right? You have scenarios where the device is not necessarily owned by the operator, but it is any sort of update or firmware update that needs to happen on the device needs to be authorized by the operator, right? So from a service perspective, it is actually owned by the operator, right? And any firmware updates have to be authorized and right. So the device manufacturer, for example, might issue a firmware update and say, this is for the latest firmware update for a device. But the network operator is going to say, unless I've certified that a version of firmware and I have authorized that firmware to be loaded on the devices that are currently on my network, I don't want that firmware to be sent down to that device. Right? So it's not necessarily that a binary situation where the device owner and the network owner, I mean, these are owned by one or the other.
Robin Wilton, ISOC. I personally do not want the architecture to assume or to be based on the assumption that the operator and the network are the same entity. And I have a kind of an in principle argument and an in practice argument. And the in principle argument is that if you do that, it tends to favor the walled garden model of proprietary IoT deployments. And I think that's something we've learned from previous experience, is that the interests of the consumer and the end user tend to be better represented once technology moves beyond that walled garden phase and you get open systems. So that's the in principle argument. The in practice argument is more to do with trust and network services. And it's about the ability of a third party to interpose themselves on the user's behalf between the vendor and the device on the user's terms. We've seen this with personal data, with services that can broker terms and conditions on behalf of the user relating to the use of their personal data by third parties. And so that is both an economic and a technical model where you want that ability for a third party to interpose themselves as a trusted broker on behalf of the user. And I don't see that being favored by the model where the architecture assumes that a unitary ownership. Thank you.
We're going to cut the mic line here.
Eric Nordmark. So Michael brought up a few cases. I don't think it's actually that complicated. There's one thing that he brought up, which is the going on the trip example, which I don't think is about the image or the manifest and whether they're validly signed and how they're verified. It's really about being able to control when they're applied. And the notion of if there's some outage associated with applying a firmware update, even if it's for 10 seconds, right? Somebody in that chain of control might want to say, this is when I want to apply it on Sunday morning at 3 a.m. or, when someone is actually watching it. Right? So I think that's a piece that we could externalize that way. The notion that you can have somebody, a more complex relationship, well, if the manifest signer is different from the image signer, which, by the way, the terminology doesn't currently allow because there's only one author. But if you have that, well, then you can say if car manufacturer X has something where they sign the manifest, maybe some third party produces the image, whatever the relationship is, they can then say, well, I'm going to take into account what the Department of Transportation is saying. So you can feed that in there saying that, okay, this thing must be applied for you to be able to drive past Sunday or whatever the rules are. There has to be some timing pieces in here as well. But you don't have to say that the device has to be able to validate more than a signature of the manifest and a signature of the image or images, plural. Right? You don't need multiple signers of the manifest, as far as I can tell. Externalize that stuff and make the upstreams deal with it.
Brett, I agree with the person two in front that I don't think we should assume that they are the same, and artificially limiting ourselves to one or two signers may not prove to be long-term effective. So I'm kind of short, so I have to kind of stand up.
So talking about the broadcast delivery, I'm more talking about
Hold the mic down.
I'm more talking about on the wireless network. On the 4G, we only support the multicast delivery, not support the broadcast. Based on my understanding, even for the 5G, 5G is not defended finished. Or maybe also only support a multicast, no broadcast supported. But anyway, even maybe broadcast or multicast, broadcast is supporting the fixed network like Wi-Fi and multicast in the 5G, 4G. Something we need to be careful. If multiple huge number of UE at the same time download the image, same time finish the application, at the same time access the network will create a huge signaling or data network connection to the network. In such case, we need introduce some random delay in the UE side and make the access the network or deliver in the some make not surge the network.
Yeah, I think we don't want to go into protocol details like the difference between multicast and broadcast. The tech should be agnostic. But what is important in that section is really if you need to be friendly to broadcast, that means that the part that is friendly to broadcast can't really carry individualized information per device. That's anything that is per device has to be separated from the part that's bulk transmitted to everybody. And so that is a constraint on the way that the manifest and images are packaged, if you will. So is the manifest contain only stuff in it that can be sent to a large number of people, or is there individualized stuff that's in there? And that's the constraint on when we get in the manifest format and why it's important in here. Exactly whether it's multicast or broadcast or whatever is the protocol part, which is out of scope of the working group, except for the parts of the constraints, like I mentioned. You have to know what the constraints are. So, okay, thank you. The point of going through those was to say those are the things that we know are sort of the open issues, at least in the text, right? Because now if we have directions and some of those become just editorial, making the text do that, okay? And so we had a call for adoption that we started after the interim meeting. The draft was then updated to address the comments in the interim meeting. There are still some open things there, although that was I haven't seen anybody else's review per se, other than, yes, I like the document, but I was the only person that did the review, and I just went through all of those. My personal opinion is all the things we've talked about are things that can be done by the working group. None of those are prerequisites to adoption. Okay, that was my opinion. And so here we said that the call for adoption of the last document, the one that Hannah was up here presenting, was concluding at this meeting. And so we've already asked the list, and so we don't have to ask the list because that's been going on for the last week or so. It ends now. And so now we ask the meeting room to say, okay, so far we have heard support for adopting that document as the starting point and then rolling other information into it, okay, which we've been talking about here as stuff that would go into it if we adopt it. So now we will conclude the call to ask the room now is, do you believe that this document is a good starting point for the working group, okay? And I'm going to ask, if you think it is a good starting point, I'm going to ask you to hum. And if you think it's not a good starting point, I'm going to ask you to hum. And our area director is over there, so she can tell if it's awaited. Okay. All right. So, and if you're going to hum no, then I'm probably going to ask you to come to the mic and say why, because nobody on the list has yet. But let me do the hum first. Okay. If you believe that the document is a good starting point and we should go ahead and adopt it and then continue to work on it, please hum. If you believe that that document is not the right starting point, please hum. Okay. I claim that that is a clear consensus, and it has already been confirmed on the list. And so the next version of this should be a draft IETF suit. And so are there any concerns? So yeah, we've talked about that one, and there are some follow-on ones, which I think Dave is going to cover next. So sure. I'm going to hand it off to him.
Yeah, so as a result of this, we'll want Hannes and Brendan for you to post the next version of this as draft IETF suit. Let me switch to the. So, Dave Waltermeyer. So in preparation for this meeting, the chairs were talking about, we're reviewing our milestones, and we realized that we actually have a milestone around creating an information model in addition to an information model for manifests in addition to the data model work that we've been doing. So what I wanted to do quickly here is to give a brief overview of what the difference is between an information model and a data model. So the relevant RFC in this case is RFC 3444, which discusses these two concepts. And that RFC defines an information model as a model of managed objects at a conceptual level, independent of any specific implementations or protocols used to transport the data. So really at this level, the degree of specificity for an information model is really at an abstract level. Things that an information model should be defining are the basic data elements that we're talking about, whether they're required or not, and what the cardinality of those data elements should be. Is one allowed, or do you need to have 3 of them? As well as maybe some abstract typing information, like we're talking about strings or numbers or or those sorts of things. But it's doing that at a level that typically is not implementable. What does do that at sort of that lower implementation level is a data model. So RFC 3444 defines a data model as sort of a lower level of abstraction that includes the implementation details. So the idea is that an implementer, someone who is writing code against the data model, would have basically all of the information described in the data model in order to inform that implementation. And so the idea is that by defining an information model, that enables a group to then define multiple equivalent data models, or at least equivalent from the perspective of the information that they express. Next slide, please. So that brings us to, I think this is not the updated slide.
No,
I think I can cover it anyway. So that brings us to the question of how does this working group move forward as far as providing an information model for a manifest? Well, I think one way of looking at this problem is we just adopted a partial information model for a suit manifest. So specifically looking at section 6 and or was it section 6? Ah, yes. So in the current architecture draft, we have section 6, which talks about the manifest and provides some high-level requirements for a manifest. And we have appendix A6 that provides a few additional details. So one of the things that we would like to propose is that since we already have since we've already adopted this draft, maybe as part of the next step that the authors take is to break these sections out into a separate information model and to publish the original architecture and information model documents as working group drafts.
This is Hannes. That sounds fair. I was just looking for a little bit of guidance on what information model language should ideally be used. So currently the figure is a sort of a kind of incomplete UML representation. One could argue that UML is a reasonable information model description, but of course there could be other things selected as well. Currently it's not quite there, but
English is fine.
Oh, that's an interesting information model.
Right.
Okay.
So speaking as an individual, I've seen these sort of information model efforts go sideways when we start to talk about using existing data models to express an information model.
Okay.
I've typically found that where they've been successful, we've kept largely to human language.
Okay. That's
Yeah, so
that's
just to
good
put,
advice.
English is fine. I think just what Dave mentioned before is things like what is being represented. Is it conceptually a number? Is it conceptually a DNS name? Exactly how it's encoded is irrelevant as to whether your numbers are encoded as strings. Those are all data model things, right? Like JSON encodes numbers as a string, right? In the JSON, all that is below the level. So is a number a string or a UID or whatever? The cardinality URL, the cardinality, is it mandatory or optional? Those things need to be answered, but nothing about the actual encoding itself.
Yes.
Dave Kemp. I've been working on several standards where information models are expressed as tables within a document. And having cardinality, in particular, English prose isn't as good as at capturing all of that. So tables or a language that can capture table-like information. Google Protobuf has an IDL that is an abstract level, even though their encoding is fixed. But that language looks like a candidate.
Tables are great for such things.
Thanks, Dave.
Hello, this is Mace from University of Essex. Just a quick note on the data models. Recently, there has been rapid increase in adopting YML as a language. It's similar to JSON and it's very well human-friendly. So just a suggestion for expressing data. What I'm more interested in is actually the relationship between information models and data models. And coming from an ICM background, that especially that you are decoupling the data from the information models. So maybe a suggestion for the document is to include an example on like 1 or 2 examples about how information models relate to data models in 2 different possibly scenarios. Not to say that they are specific to it, so not to avoid such a misunderstanding, but just as examples, so one can see how they relate. Thank you.
So 3444 sort of does that, and we don't actually have a milestone that says that we need to do a data model. What we have to do is we have to do an information model, and we have to do a particular manifest format, which is a particular serialization. And so I don't want to get into the discussion of whether a data model includes serialization or not. We can avoid the term data model whatsoever in any of our documents and only talk about manifest format and about information model if we want to, because that's all the charter directs us that we have to do.
Yes, that's actually true. It's always confusing, the use of terminology
Yeah, yeah.
between data
So
and
my preference would
information.
be, let's not use the term data model in this
Yes.
working group.
But the description, the relation
Yeah.
between any two independent models
But that-
is
that-
the most important.
And that's what 3444 is.
Right, and including a few sentences on that is probably appropriate.
This is Brendan. I'm quite happy with the idea of having a full justification flow from usability and security requirements all the way through to the actual information model. So I'm quite happy with taking the output of the threat analysis and so on and turning that into the information model.
Yeah, one of the questions would be, well, I don't know, we had another slide after this, but in the, where is it? The one that we were just on.
Backed up to, because the speaker was talking.
Oh, yeah. Certainly section 6, which is the one that's labeled manifest, which is relatively short, and section 8.6, which is one that has the long thing about all the manifest fields, okay, which is great. Certainly both of those would be sort of inherently information model. Most of the rest of the appendix are things that then motivate what goes in the information model. It could be that we choose to say all of the appendix moves into the introduction part of an information model document, or it could be that some of it stays in the architecture. There's a little bit of flexibility there as to say which parts move and which parts would stay.
It seems to me that given the number of forward and back references, it might be useful to keep them together.
Right. My personal opinion is that take section 6 and all of appendix A, put those in a separate document, call that the information model document.
Thank you.
With Dave Kemp, I would agree that, something like a property table would be a great solution. But I also agree with the lady that just spoke, making sure that we have solid examples that show how things are actually usable. Sometimes in a lot of the documents that come out of IETF or other standards groups, it's really a significant jump to figure out how you actually implement and use. So.
Okay, so I'd like to do a quick hum just to confirm what we're talking about here. So I'll do 2 hums. The first will be hum if you're in favor of converting section 6 and appendix A into an information model document, which will be adopted as a working group draft. Versus no, no, which is we will continue to solicit information model documents using the traditional mean. So if you would like to see the information model content in the existing architecture be adopted as a working group draft, please hum. And if you're opposed to doing that, please hum. Seems pretty clear, yes. Okay, so we will for the authors of the architecture, is it clear to you what needs to be done to produce both documents? I'm seeing head nods. Okay.
Okay, so that's the one. That's what you just do.
Yeah. So in doing that, it looks like we will be able to satisfy adopting a manifest information model as of this meeting. And our next major milestones are to adopt an initial manifest serialization format as a working group item
Or
formats, which is something that we still need to do. In July of this year, so at the next IETF, we should be prepared to submit a manifest information model to the IESG. So we have some work to do there. We're going to need a lot of document reviews.
Maybe.
What's that?
Maybe an interim meeting.
Right, and we may want to focus some time during a virtual interim to have some discussion of issues relating to the information model, and probably also for any manifest serialization formats. And then hopefully in November we'll be prepared to submit
an initial manifest serialization format to the ISG for publication. So I believe at this point we should probably take to the list planning a virtual interim to start working on these items. Okay. Next slide.
You got to switch over to that.
Yes. Okay, please go ahead.
So this is just a quick overview of the contents of the manifest serialization, I guess I should say, as it stands. This was the one that was published in the third version of the manifest draft. Next slide, please. So the criteria that we used to put this together were the ones that we've just adopted as an information model. The format is designed to fulfill the usability criteria and to mitigate the threats listed in the threat model. Next slide, please. So for an encoding, we've been discussing a variety of different encoding possibilities. The one that seems to be the standout is CBOR from the input on the mailing list. So we have redrafted quite some time ago now the manifest format in CBOR and COSE. Next slide, please. There, what I just said. Is everyone happy now? Okay, next slide, please. So one of the standout points that's not particularly clear in the remaining slides in this deck is the use of CBOR maps. So we've treated them as enums. However, to allow for some flexibility in implementers, what we've done is reserved positive integers for items in the standards document and negative integers for use for customization. Next slide, please. So we have the version of the manifest format specifically. This has been a bit confused in the past when I've seen drafts of this. There have been certain instances of people believing that this was specifically the version of that particular manifest. But this should be relatively clear now, I think. Next slide, please. The textual description field is a map of possible different descriptions. We have described 4 of them so far, being a description of the payload, a description of the update, which is not necessarily the same thing, a description of the vendor and of the model to which the update applies. Next slide, please. This is just a random value, the nonce, to guarantee that every manifest is unique. Next slide, please. There's been some debate about this one. Ideally, this is a monotonic sequence number. We've called it a timestamp because that provides a convenient way of ensuring that it is a monotonic sequence number. Next slide, please.
You want comments on that? Or do you want
Comments? Sure, comments. Stop me anytime.
So I think the controversy was whether this actually required real-time clocks on devices.
And in fact, this is just for comparison purposes between 2 different manifests. So it is a monotonic sequence number, but a timestamp makes it easy to synchronize between different developers.
Are we going to call out the type of timestamp and what level of precision that timestamp is supposed to be at? Brett Jordan.
What I have been using so far is a Unix timestamp. I am open to suggestions as to whether that is appropriate or not.
Yeah. I think all you care about is the number is higher than the last time that the manifest got sent.
That is absolutely correct. Yes,
And
it
so
is.
as long as you're not sending more than one update per second, then that's fine.
So,
Right. And to your point about the real-time clock thing, I think that the point is that the receiver is treated as an opaque integer. It's only a clock from the sender's perspective. The receiver doesn't care whether it's a timestamp or not. It's just using it to compare for greater than or no, right?
That's absolutely right. Yes.
This is Hank. But I totally get the idea that a time is monotonically increasing and you're having a requirement satisfied here. It is maybe a little bit complicated to use time. Just not everything has a time source. I think you should be able to make sure that you monotonically increasing your index. If you cannot do that, please do not do firmware. And then also, it is a big thing, and you force people to use a special representation. And I'm building a reference model for time representation, and it's awful. And time is very, very complicated, and we can make many things wrong there. And clocks are faulty. So every second, some clocks cannot do that even precisely. Maybe not a timestamp. And it's big also.
Ted Lyman, just to reinforce what Hank said, the other thing is, like, you're using a timestamp to protect firmware that you don't want to get attacked, and you're going to use a timestamp that expires in when is it? 38? Just doesn't seem like a good
uint is
idea.
a 64-bit. It should be fine.
uint is a 64. Okay.
Okay, so
Sorry, Janos. So I just would like to second what's been said before, that if we use that it's a timestamp, it can lead to many misunderstandings, and implementers might misunderstand it both on client and server side. And if we just say that it's a monotonically incrementing integer, it's much more straightforward and safe, in my opinion. Thank you.
Thank you. Okay, we'll have to do some more work on that then, I guess. Okay, shall we move on? So we've got conditions and directives. These are intended to encapsulate all of the different ways that you might decide whether or not a firmware applies to a device, and then what to do with it once you've decided it applies. Now, right now, the only two directives that are defined are whether you want to apply immediately or apply after some time. This is a list that probably needs some more filling out. There are a few other ideas that we've had on what kind of directives we might use, but for the moment, those are the two. And in fact, there was one from earlier today, which would be apply after a random delay to reduce network load. So that might be another interesting thing to add in.
I'm sorry, this is Hank again. Reading just from a very high view, the terms conditions and directives, that I don't want to be the bad guy here, and I don't recommend to use it in full, but it brings ECA to mind. At the moment, a lot of people are using ECA, the event condition action thingy, and that's probably what you're having here. You have a condition, and then you have an action you want to do. That's your directive, I guess. So maybe look into that and align a little bit with that. That would be less another wheel than this seems to be.
The one point about having conditions listed in the way that they are and directives in the way that they are is that the intent here is that you match all conditions before you apply any directives.
Okay, there is an if. How? What
I'm not convinced about the text on the right hand side.
Okay, see, that's here, and that's why I brought the ECA thing up, because it's very too complicated, I guess.
Yeah.
And that goes into the direction, and maybe not make it complicated and something else entirely, or you maybe align with the ECA. Either you have to decide how complex you want to be there, I guess.
So Hank, you expressed an interest in having us align with ECA, and you said we should align with that. What is that we would be aligning to?
I mean, there was once a working group called Super that imploded on doing something like that. So let's not do that. And there is I think in Yang, there is a automation control framework draft, a generic one that is using ECA in a way less complex way, and maybe look at that draft, and I would like to refer that as a first reference that comes to mind.
Can you maybe send some pointers to some of these documents to the list?
I will, yeah, try.
Okay.
This is Hannes. Carsten had suggested to use the term claims here, but in essence, regardless of what exactly the terms here are, the basic idea is fairly simple. We wanted, based on the description of the architecture document, we wanted to have the possibility to express that a specific update is only applicable to a certain device, and somehow you need to shove that information in there. It happens to here in this version, the condition terminology is used for that, and then there's something that you take as an action afterwards. So I don't think we are creating a very complex mechanism here, hopefully, specifically since we are talking about these constrained devices. So this is not a arbitrary language that goes in here that does all sorts of fancy things. And if you look at the 4 different conditions that we have defined so far or proposed so far, that's really to nail down on which devices you want to do the update for.
This is Hank again. Then I would just recommend not to call it a condition. It's a template or a set of attributes that describe a thing. It's a description. It's a thing description. So it's describing the thing. It's a vendor. It's a class. A device. That's basically describing the thing, and it's a description.
One of the other conditions that we've batted around, which isn't in here yet, is, for example, a minimum battery level that's required to be able to apply an update.
Okay, that's state of the thing. Okay.
Yeah.
So we're going a little bit more complex.
Yeah.
Best before maybe best before it's empty. Yeah. I get that now. Better than before.
So best before is a date based.
Okay. So there are multiple best befores. Okay. It's a yes. Yeah. Go ahead.
Rick Taylor, I think the word we're looking for is prerequisite. The device must match the following conditions, but I'm avoiding the word condition. What are the prerequisites to applying this?
Sounds reasonable to me.
So best before, I think, is the example of the one that if you believe that these are conditions that should be checked by the device itself, if the conditions are ones that are supposed to be checked by the device itself, which is one of the possible places that could be checked, but if it's checked by the device, I don't think the device can check that without a real-time clock. And so that is problematic.
Correct, yes.
And so either you have to say that the best before is okay to ignore if you don't have a real-time clock, or you can say that this is one of the justifications to use a different protocol that checks it somewhere else, right? Either of those are valid approaches. So.
Thanks, Dave. We need to cut the line. Sorry, Stephen.
Okay, aliases is a mechanism to redirect to other servers. So if you have multiple possible storage locations, or indeed if you are attempting to redirect a device on a different network where there are multiple manifests or perhaps countersignatures involved, then this would be a way to provide that mechanism of essentially customizing a dependent manifest to an individual network or an individual customer set of requirements. Next, please.
Dependencies?
Did we skip one? Dependencies, yes. Dependencies are links to other manifests to handle other kinds of prerequisites. And extensions being effectively a derivative of the X509 extensions concept. So that if we miss something in this working group, there will still be a place to put it. Next, please. Right, the payload info structure deals with the actual description of the payload itself.
So you don't need the extensions. You're using CBOR and CDDL. And so any new thing you add into your dictionary is there.
The current implementation is an array.
Pardon me?
The current implementation is an array.
You can still add things to the array. You're saying that's the order in the array?
Yes.
I think that's a mistake.
Is that it?
No, yeah. Okay, keep going. Yeah, so there's I'm proposing one change, which is that we use ranked URIs for aliases, because there may be a need for more than one possible redirection in any given network. And evidently more changes that I will take into account.
That's it.
Hi, this is Hank. Just one final comment. I don't know, that's not from me. I'm relaying it. I'm remembering it, but I don't know who said it. Maybe manifests rely on manifests.
Yes.
Is that a reference?
Yes, that was the dependencies section.
That was a dependency. So that it is the dependency is another manifest,
That's
not
correct.
I don't know some random resource. Okay, I wanted to make sure of that. Thank you.
Would you post something about your proposal to the list, just to close that issue? Thank you.
Markus Güller. I had just a comment to the initial question if everybody was happy with CBOR or COSI. And I wanted to link back to what Hannes said in the beginning. For that, it would be very good that we can get some libraries or code which is running on constrained devices.
Right.
Because it would be very important, you know, if you're going to implement that, to get a feeling of the footprint of what this takes, how does it work on this constrained devices in the bootloaders. And I just want to make this link back to what Hannes said in the beginning.
Yeah, and I mentioned earlier, maybe we can meet up here after the meeting to talk about how we might start to close some of those gaps. So if you're interested, please come up after the meeting. Okay, so I think we're going to move on. Russ has a very important piece of business to take care of before we conclude.
Kathleen, could you come up, please? So most of you are probably aware that on Wednesday at the plenary, Kathleen will be stepping down as Security Area Director. So the chairs were trying to come up with a suitably gift for this event, and we hope we have picked a suitable activity or gift for this event. Kathleen, thank you so much for helping this group get started, and here you go. You can.
Thank you very much.
Okay, I think with that, well, we have how much time left? Are we?
7 minutes.
We could. Does anyone have any other business that they would like to raise before we conclude?
Yeah.
Which one?
Who wants to talk about the library?
Yeah. Yeah. Does anyone want to come up and talk about the library?
If you're not interested in talking about the library, session over. If you're interested in talking about libraries, come up here.
Sounds good.
We're done. We're done.
All right. Thank you, everyone.
Thank you.
If you haven't signed the blue sheets, please come up and do so.
It was like 10 pounds.
Whatever you think. Yes.
You have. Oh, you only have.
I only have one.
Okay.
After I clean.
Thank you.
What do you do next year? I would say. Are you interested in Almost. Almost, but it's no, I'm here for slightly closely, but not exactly that much. So, and also I talked to Carsten and Jim about this, that now it's getting more earnest, more serious about having a change, and they both are pretty much aware after they have seen all of them visit you at the table.
Yeah, I got on Jim's nerves.
Yeah, it is okay to do that because this way of composing things is somehow unnerving.
But he was very friendly, don't get it wrong. He had me all points, and so that was great.
But yes, I will push more.
Maybe we get some list conversation. We just really need someone to kind of volunteer and stuff.
I have one high-level question. I was not familiar with this ACE until this morning, so I looked into the document, and person used a lot into ACE. So isn't there any lot? Or it's supposed to constrain devices, or did I miss something? How does the whole ACE stuff
environments that are not constrained.
No. I have a guy who uses COSI and zero.
Yes. But the way you do this, you don't take Jim's library and just to take some code and get it, and then it keeps locally and not. Okay.
Because
Yeah, I was just wondering, cozy there, cozy there, cozy there.